Today, I'm taking my DIY winding machine to the next level. We're upgrading the system to handle much larger motors, specifically the heavy-duty stators found in e-scooters. As you can see, compared to the standard drum motors, these stators are significantly thicker and heavier. To move these beasts, we need some serious mechanical upgrades. To handle the increased payload and torque, I'm swapping out the old T8 reed screw for the bolt screw in your rail guide. This is the kind of hardware you usually see in these industrial CNC machines. To get the precision I needed for this build, I sourced my custom components from JLCCNC, that sponsors today's video and my go-to CNC fabrication service. JLCCNC specializes in first turnaround, high precision custom parts for the makers and engineers. Whether you need a one-off prototype or small patch production, they offer transparent pricing with no hidden setup fee. They utilize advanced 3, 4, and 5-axis CNC machines, ensuring that complex mechanical assemblies, like the one on this winding machine, fit perfectly every time. What I appreciate the most is speed. They can turn orders around in as little as 3 business days, which is lifesaver when you're iterating on design. Right now, JLCCNC is offering new users up to $123 in coupons, with CNC parts starting at just $1. If you have a project that needs professional grade parts, check the link in the description. Here's how you can order parts on JLCCNC. Go to my video and copy this link and go to this website and click order now and upload your 3D model. And select material and types and surface finish, and you get instant quote here, and you also can get coupon over here. Click submit order. That's it. Let's look at this part. The machine is beautiful, but actually had a small design error here. If you look closely, the hole on the right has a counter bore, but I forgot to add it to the hole on the left. This was entirely on me. It's a good reminder to double check your CAD files. Now for the core rotation assembly. This is a 25mm diameter shaft that will serve as the main stator axis. To ensure there is absolute zero play, I'm installing into these bearings and timing gear using a freezing fit. One of my biggest concerns was whether this BE4108 gimbal motor could actually handle the inertia of 3.95 kg e-scooter stator. To my surprise, it's proving to be up to the task. I'm currently running it under closed loop angle control, with driver side voltage limited to just 3 volt. As you can see, there is some visible wobbling. I definitely need to spend some time optimizing the PID gains to smooth out the motion. But the core takeaway is that the BE4108 has more than enough torque to manage this heavy payload. One final challenge. When you are winding a large stator with high torque, preventing horizontal vibration is critical for a smooth, consistent wind. Industrial machines usually solve this by clamping the stator from the back or side using pneumatic actuators. For a DIY build, however, pneumatics feels like overkill. They add too much cost and complexity. Instead, I want to tackle this using a purely mechanical approach with these gears. To be honest, I haven't finalized the entire design yet, and I'm not 100% sure if this specific gear-driven mechanism work, but my goal for the next iteration is to reach the minimal viable build and put the theory to the test. Thank you so much for watching, and I will see you in the next update.